Hello everyone, today we start a big section on web development. We're not gonna go through boring lessons on HTML, CSS, Ruby, JavaScript and so on. In fact, we'll try to move away from the very term programming. And here I'd like to say a few words about the future of programming. In the next 5 years, the world of programming will definitely change and become very different. It's already becoming impossible to keep up with all the changes. Programming languages, their structures, integrations, platforms, and how everything connects with hardware. Things have become too complex and ambiguous. If we don't abstract our approach to programming, it will soon be impossible to truly understand web development at a deep level. So how do we stay relevant? How do we stay productive? And how do we create instead of getting lost in code? First, stop listening to text-based programmers and move toward object-oriented thinking. Unfortunately, there is very little information about this because 99% of bloggers talk about what they are already comfortable with. For them, moving to the next level would mean leaving behind their existing knowledge and experience, because those skills may no longer be relevant here. And in general, will it even still be called programming, or will it be something else, like architecture and logic, design and creativity? So, about web development. From my perspective, and this is just my opinion, I don't claim to be absolutely right, feel free to correct me in the comments, the share of web-related tasks among all tasks connected to computerizing processes is relatively small. I would estimate that web tasks, meaning tasks involving the internet, make up no more than about 5%. So, where is everything else, you might ask? An average person who spends all day on the internet often doesn't even realize that beyond web applications, there is a huge market. Manufacturing, services, banking, security systems. Even something as simple as a parking gate, when it opens, there is still some kind of software behind it. Every microcontroller needs its own firmware. Even in a digital thermometer, a washing machine, or a scale, there is embedded code. But since about 90% of online content about programming focuses on web development, I also decided to dedicate a few episodes to this topic. Web development is relatively easy to demonstrate. You can quickly build a web page, show your idea, and it creates the impression that you can immediately monetize it. But is that really the case? That's what we're going to explore, using tools from NI, National Instruments. For now, we won't overcomplicate things, and I'll start with GWeb development software. NI GWeb development software is essentially a standalone web application builder that runs in a browser. This software is designed to give you the ability to create and deploy web-based user interfaces, dashboards for LabVIEW, NI Web Server, System Link, and other data sources. GWeb includes its own editor, compiler, and deployment tools. Later, when we start using the full capabilities of GWeb, for example, to control computers over a network or run our own web server, we'll need additional tools from National Instruments. But as I said, let's not overcomplicate things for now and start with something simple. Today, we'll create a basic application and deploy it on a server. In my case, I'll use Bluehost since I already have an account there. If you don't have hosting, there are plenty of free options available. You can easily find them online. One of the simplest options I can recommend is GitHub. Just create an account there, set up a repository, upload your website, and follow the instructions. It's quite straightforward. So let's start our first website. I open GWeb development software, create a new project, and name it right away. I choose a location, a folder, and name the project project1_livecamps. We'll create an absolute application, a fixed layout, rather than a flexible one. We'll go into the differences later. But for now, I can just briefly say that absolute means the layout does not adapt when you rotate your phone, it stays fixed. Flexible means elements like fields and tables adjust dynamically to screen size. But let's not overcomplicate things. Our goal today is to build something as simple as possible. So what do we see in our project? We see the front panel and the back panel. The front panel is what we'll see on the screen of our phone. Right now, I'm focusing specifically on a mobile application, although, of course, this app can also be opened in any browser, including on a computer. On the front panel, I'll immediately create a window that matches the size of a smartphone screen. I know that the size I need is 400 by 750, so that will be the size of my user interface for today. This window will appear in the browser and correspond exactly to the screen size of the smartphone. We also have the back panel, where all of our backend development will take place. There's also an icon. If we decide to use our application as a reusable object, we can create an icon for it, essentially enabling inputs, arguments, and standard outputs. Next, we have the build panel. Once we finish development, the final step will be to build the application for deployment to hosting. To create a build package, we right-click on the project, New Package Installer, and then change the output type from Package Installer to Package. Later, we'll fill in the remaining fields. We'll come back to that. The build package will include an index.html file and all necessary supporting files. In other words, it will be a fully ready, structured website. If you've been following us from the beginning, this process will already be familiar. If you've just joined our channel, I'd recommend watching the earlier episodes. The terminology and concepts here follow the same logic. So let's go to the back panel to the block diagram. Here we already have a while loop, but I need to add an event structure as well. I could add it separately, but instead I'll delete this while loop and go to program flow, where I can directly place an event loop. The event loop already includes both the while loop and the event structure, so it's more convenient. Since web applications don't have a stop button, I set a constant false on the stop terminal. My first event case will be timeout. And I'll set the time to 100 milliseconds. Now I switch to the front panel. I won't focus too much on design right now, we'll cover that separately. I'll use standard controls without changing fonts, colors or styles. And maybe I'll only adjust sizes slightly. The first element I place is a tab control. I'll create 5 tabs in advance. The tab control will be resized to match the size of my user interface that I defined earlier. Next, I add the first button, text button, and name it Enter. We added the name of the button label in the Properties panel on the right. And here where the content field is, we added the name of the button itself. Uncheck Show Label and keep only the button text. Then let's position the button roughly in the center. Next, let's place a timestamp. I align it under the button Enter and center both the value and its label, top center alignment, and click Save. Then let's add a URL image element and stretch it to fit the layout. Next, from the menu, let's add text and type Live Camps. Set it to size 14 and bold. I duplicate this text and expand it below, changing it to Surveillance in Real Time. Finally, let's add another URL image placeholder. This will be used to insert our logo later. Now we go back to the block diagram, back panel. First, we bring in all the unplaced items. For now, we've only created the home page. Next, we need to add links for the logo and the image, so we also add a string constant. We find it in the menu. Then for the tab control, we switch it to an indicator and set the constant to 0. Now we create a new event case in the event structure, button Enter. From the tab control, we create a reference, change it to right, select value, and connect to a constant. This constant will be number 1. Now we return to the front panel. Let's add another button and name it
More live cams.
Next, I insert a URL image. This will display the webcam feed. To keep the design consistent, I copy the existing text elements we already formatted and paste them here. I'll adjust the text later. For the URL image, I rename it to webcam_1, remove the label, and duplicate it using Ctrl so the size stays consistent. Then I copy another text element and add a new button labeled back to main page, and remove its label and keep only the button text. Now I add descriptions for the cameras. Webcam feed will be from Philadelphia, Pennsylvania and Monterey, California, US. Next, I duplicate these buttons and elements and place them across tab 2, tab 3, and tab 4. Now we just need to update the text for each tab. For example, on tab 2, we'll have a camera from Boston, Massachusetts, and on the following tabs, other locations. Now let's move to the block diagram. Here we have 16 unplaced items, and now we'll work with them. I'll add links for each of them, essentially repeating the same steps I used earlier for URL image logo and URL image home. I'll do this for all webcam elements, insert the links, and create event cases for the remaining buttons. Alright, now the program is finished. The green arrow indicates that there are no errors. At this point, I have two options: run the program inside my IDE or run it in the browser. First, I test it in the IDE. Everything works. Buttons respond, cameras load, tabs switch correctly. Now I stop the program and click Run in the browser. The build process starts and the page opens in the browser. This is how it looks on a computer. Everything is working properly. The only thing left is to remove the visible tabs. I go to the layout settings on the right, disable Show Tabs selector, and remove the label. Done. Let's save the project. Now I move to the build step of my program. Here I need to add the file and fill in the details. I enter myself as the maintainer and provide my contact email. And let's name the package LiveCams. Before building, I go to Documents and set a custom title. I'll name it Laplanda. Then I return to the build section, I check the output directory, this is where my project files will be saved, and click build. The program is now being built. As you can see, I didn't use HTML, CSS, JavaScript or anything like that, and the application is already ready. Now I open the folder where the package was created. Inside we see index.html and all supporting files. So now the only thing left is to upload these files to my hosting. For that, I use FileZilla. I've already explained in previous episodes how to connect to hosting. Here I created a folder for my website called LiveCam, and now I simply copy all the website files into that folder. Advanced web designers might say, I can build a page like this in a minute using ChatGPT. And yes, that's absolutely true. You can generate a page like this with a single prompt, even more complex pages, even multiple pages. But what happens next? As soon as you want to extend functionality, add logic, create interactions, ChatGPT alone won't be enough. You'll need to build a programming flow, which means diving into HTML, CSS, JavaScript, and all the underlying structure. And that's where you enter the routine of traditional text-based programming, where very often the headaches begin. In our case, everything remains visual, clear, and structured. You focus only on creativity, logic, and architecture. And all the routine work is handled for you by GWeb. Well, I didn't even finish speaking and the transfer is already complete, which means the website is now live on my hosting. From anywhere in the world, you can access this page and see the webcams. But here's the catch. The URL of each camera is hard-coded into the program. It can be changed. So in its current form, this application is actually not very useful. And this brings us directly to the topic of monetization. Selling a program like this, probably not going to work. So what needs to change for it to become valuable? You need to make it flexible, meaning to allow users to replace the camera URLs. For example, imagine someone has a parking lot, a store, or any property they want to monitor with webcams. They might have multiple cameras. Your application should allow the user to enter their own camera URLs, save them, and use their own video feeds. Once you add this capability, the program transforms from a fixed, one-off solution into a universal product. And that's where real value appears, because now anyone can open their phone at any time and instantly see what's happening on their own property, which is actually useful. In the next episode, we'll build a mechanism for this. Specifically, we'll create a settings page where users can save their own camera URLs. By the way, later on, we can also explore video processing capabilities. For example, we could detect license plates, recognize human silhouettes, track movement or lighting changes. And based on that, we can trigger alerts, such as sound signals or pop-up notifications in the browser. All of this is possible thanks to our IDE, Integrated Development Environment, LabVIEW. As for my projects, I'll package each one into a zip file and include a download link in the description of every video. You'll be able to download the file directly to your computer. In the next episode, we'll expand the LiveCams project, we'll add URL saving functionality and explore ways to monetize this solution. And that's all I've got for today. Thank you for joining Laplanda Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.